So solve algebraically the simultaneous equations. Okay. A key strategy here is to always use the linear part of the equation and substitute into the quadratic part. That's really it. And what you should do is firstly make like something easy subject like y. I would make y the subject for the second equation, and it will look a bit like this. You would have to plus 3x across, so it would be 3x plus 13. This would be the key variable to substitute into the quadratic equation. Oh, yeah, I'm getting a bit tired now. So let's try and wrap this up. Since we know the value of y, which is 3x plus 13, that means the value of y squared is all of this term squared. So rewriting the first equation, we'll have now x squared plus the new variables 3x plus 13 squared, and must all equal 25. And now we just go ahead and finish this off. So expanding the brackets, so we've got x squared plus, and remember, key note, this means double brackets. Okay, so we're going to have 3x times 3x is 9x squared. 3x times 13 is 39, and another 39x, and that'll make 78x. And then 13 times 13 squared is 169. Must all equal 25. Oh, so yeah, the maths gets very intense, man. Unfortunately, it's what we have to do. Now let's solve this, yeah? So collecting like terms, x squared and 9x squared makes 10x squared. We've got 78x. 169 minus 25 is 144. All right, almost done. Can we simplify? Yes. Try and divide this. You can divide this all by 2. So we're going to have 5x squared back to 39x plus 72. So always try and find ways to make your life easier. Now, what can we do here? So, all right, so you could use a quadratic formula, which I do not recommend, because then you have a b value of 39 squared. Horrible. So let's try factorizing. So first things first, I would put 5x here and x, because this is the only possible way to make 5x squared, using integers obviously. Now we need to find the correct pairs to solve this. So we need two numbers to make 72. Let's think. To make 72, two numbers that multiply make 72. Well, we have 8 and 9. Yeah. What else do we have? We also have, let's think, 18, 4 and 18. Cool. Anything else? 72 is also divisible by 3, right? So yeah, 3 and 24. All right, now this is the challenge. So the way to solve this really easily is ask yourself, okay, these two numbers need to sum or subtract to make 39. In this case, everything's positive, so you're probably adding. And one of these numbers need to multiply by 5 to guarantee this term. So for example, I'm going to just choose the last one because I've actually done it previously, but the key idea is just to pick a term. So I'm going to pick this pair. I would multiply 3 by 5. Why? Because 3 times 5 is 15. And if you added 24, you get 39. So that's it. So it'll be 5 times 3, and 24 goes there. You can test for other values, but you won't get the right answer. If you times 4 by 5, you get 20. You can never make 39, and vice versa. Yeah. So anyway, getting back to the work. So therefore, this means x is minus 3, and 5x is minus 24. And which means x is minus 24 over 5. And of course, x is minus 3. Right, so almost done. So now we found the x values, and now we need to find the y values. So actually, this is easy. You just plug in the x values into this equation. So bring it down here. So y equals 3x plus 13. Is that, yep. So we can say firstly, when x is negative 3, because it's easier to work with. So when x is negative 3, y is going to be 3 times minus 3 is minus 9, plus 13 is positive 4. So this is your first pair. Now the annoying one is the second one, is the fraction. So when x is minus 24 over 5, we're going to have, that's not what I was looking for. We're going to have now y equals, let's try and do it fast here. So 3 times 24. What's 3 times, oh my god. So that should give us 72 over 5 plus 13. And to make your life easy, because no calculator, Make 13 a fraction, so it's 13 over 1. Multiply up and down by 5 so you can add them. You should get 13 times 5 should give you 65 over 5. And yeah, now it's easy. So you have minus 72 plus 65, that gives you minus 7. So it's minus 7 over 5. So your two corresponding other two pairs would be minus 24 over 5 and this. Yeah, so always pair them together, yeah? So this would go with x equals minus 24 over 5. So two different solutions. Right. So yeah, so far so good. Alrighty, question 21. So ABCD is a quadrilateral, okay? AB equals CD, so let's write this down. So AB, this length, equals CD. And angle ABC equals angle BCD. Let's give them both the same letter X and X. Okay, so these two are equal. Angle ABC identical to angle BCD, and we can just call it X. Prove that AC equals BD. Alright, so first thing to know, yeah, these two AB and CD have the same length. Okay, so we can both call them L if you want for length. Now, the only way this can actually work is that we need to show that the diagonal AC over here and that these two are the same is by evaluating their triangles. Okay, that's the only way it will work. So let's work with ABC first, yeah, triangle ABC. So something like that, L and X. Now, just by the rules of area of triangles or general triangle property, if we just call this length BC for a second, yeah, let's call it A. Okay. Since this angle is identical to this angle, we can clearly assume that the total area of this triangle and the length itself is going to be equal or identical is the correct word, or congruent to its reflected symmetrical triangle at the points BCD, where this is line L and this is angle X. This would therefore be A. So far the angles are identical. If the lengths are the same and the angle is the same, if we had to use the cosine rule, we will come to the conclusion that this final length, let's call it B, would also be the same. Okay, so hence both B's are the same. So we can simply state now that AC equals BD. So the lines, the long lengths, AC is equal to BD. Okay, that's really it. Yeah, straightforward. You could use the cosine rule, but you're pretty much done. It's a lot of marks. If you want to just guarantee all the marks, make sure you even repeat these lengths. You can say AB. I guess I could have also stated that AB here equals CD, and we defined it by the letter L, and that works perfectly. Okay, let's move on. Okay, final question, guys. 22. So this is ranked as one of the hardest questions apparently, but let's have a go and break it down so it looks, trust me, dead easy. So the diagram shows a hexagon ABCDEF, okay, and they kind of look congruent or identical, probably. Now ABEF, so the left side and the right side of the shape are congruent parallelograms, where AB equals BC equals X. So like it says, call them X. P is on the point AF and Q is on the point CD, such that B to P and B to Q are 10 centimeters. So if you just draw a dot line that connects to P from B and a dot line that connects to Q, we have identical lengths of 10. Given that angle ABC is 30 degrees, so the whole thing, prove that you can make cos PBQ. So PBQ, between the triangle between PB and PBQ can look like this. All right, I'll tell you a very easy way. First things first, represent this as separate triangles, yeah? So I'm going to go ahead and draw two different triangles. The first triangle is going to be ABC with lengths X, X, and angle 30 degrees, because we know angle ABC is 30 degrees. So this means the only length we have here is AC. I'm also going to draw a second triangle, because again, always good to represent this properly. And I'm going to rename PBQ as alpha, just so it's easy to work with. So PBQ is alpha. So this is the angle alpha. And we know between alpha is 10 and 10. And we know that the length using at least the long side would be PQ. Now, when you begin like this, you can easily solve this now. Believe me, now we've solved it. One thing to note in this parallelogram is that because we know it's all congruent and for various reasons it should be equal, we can assume now that the length A to C is equal to length P to Q. So these two lengths are actually the same, AC and PQ. So in fact, you can go ahead and say they're the same. So we can say therefore AC equals PQ. Now to resolve this, you got three lengths and an angle. Three lengths and angle. The only suitable formula from the top of my head is the cosine rule. So let's go ahead and use the cosine rule for the very first triangle, yeah? So I could say where, you could let AC be your little a and angle be the capital A. I could say now, using the general formula with a squared equals b squared plus c squared minus 2bc cos a, that little a is AC squared. The little b and little c's are the x's. So x squared plus x squared minus 2 times x, which is 2x squared, cos 30. And the second equation for the other triangle will be the same thing, with PQ being the little a and alpha being the big A, and tens being the B and C's. So this will also give us PQ squared equals 10 squared plus 10 squared minus 2 times 10 times 10, which is 200, cos alpha. And there we go, guys. Here is our two equations we're going to work with. Okay. Now, because we know that these two AC and PQ are equal, so of course the squares will be equal too. This means that these two equations are equal to each other. Okay, so we can say now, so x squared plus x squared, so we can say that 2x squared minus 2x squared cos 30, we'll get to cos 30 in a second, must equal 10 squared plus 10 squared, so 100 plus 100, which is 200, minus 200 cos alpha. Okay, so not so bad. Looking back at the equation, they look like they just subtracted 200 somehow. Okay, so let's go ahead and do that, yeah? So subtract, okay, oh yeah, and let's firstly deal with cos 30. So to work out cos 30, if you don't remember the trig triangles, just draw your typical right-angle triangle, label 130, and use the 1, 2, 3 rule. Suppose we call this angle length 1. This means that opposite, the hypotenuse will be 2. And using Pythagoras theorem, you'll get 3 but rooted. And we're done. So cos 30 is actually identical to, cos 30, they use adjacent hypotenuse. So it'll be cos 30 equals the adjacent, which is root 3 over hypotenuse. So cos 30 is root 3 over 2. Now that actually helps us a lot. So let's go ahead and push this further, yeah? So we got 2x squared, so now we're almost done. So we have 2x squared minus, so if this is root 3 over 2, if you times it with 2, the 2 and the bottom 2 cancel out. You're left with root 3x squared equals 200 minus 200 cos alpha. Alright, almost done, guys, almost done. Now, to make your life easy, let's divide 200 across and factorize x squared here. So you're going to have 2 minus root 3 over 200 x squared. And now you're left with 1 minus cos alpha. And guess what, guys? This is practically it. Just switch the positions around, put cos alpha on the left side and this on the right side. And you will get, and I'm going to do this on the next page, cos alpha equals 1 minus all of that. And that's it, guys. I hope this idea helped. And just to keynote that, alpha, if you remember, was PBQ. Yeah, and that's it, guys. That's the end of the paper. And thank you for watching. This has been really honor, and I hope you guys enjoyed it. Let me know what you think. But other than that, I shall see you next time. Ciao.